is yours. Microphone. Yeah.
Okay, so hello, my name is Kevin, and today I will present to you guys about a burglar alarm, or we can say anti-theft alarm. The subtopic that we will discuss today is first about motivation, and the second is how is the structure. The third one is operation video, and the fourth one is problem that I face on making this structure. And first, the motivation. First is because I was inspired by a Western action movie, because the Western action movie is like one of the genre of film that I like the most. And this is a film that I watched before that inspired me. It's named Lupin, and you can watch in Netflix. It tells a story about like the thief who tried to steal like jewelry from the museum, and I think that this kind of stuff is the simple one that is used in museum. There is a burglar alarm, and the second one is it is very challenging because I like to try something new, and I thought the teacher hasn't taught us before about how to use this PIR that I will describe next. And then the third one is I think this is one of the most innovative and most useful security technology. Like many of government have applied this technology in bank, airport, and you guys can also apply it in your home. But this one that I made is like the most simple one. And the next, how is the structure? I'll divide into three parts. The first one is the components, second one is the specific details, and three is the codes. And the components start from Pico boards, jumping wires, piezo buzzer, LED light, and resistor with 220 ohms. First, and then the component is there is also PIR. So PIR is a passive infrared sensor, and actually this PIR sensor is used to measure the infrared light from the systems that appear in your point of view. And this PIR sensor is, I think, it's the most hard sensor to be understand than the other sensor. And this PIR sensor has two slots in it, and each slot is made of special material that is sensitive to IR. And this is how it works. So when a warm body like human or animal passes by, it first intercepts one half of the PIR sensor, which causes a positive differential charge between the two halves. And when the body left when the sensor doesn't find a warm body like animal or human, then the sensor will change the differential into negative one. And this is the circuit that I drew before. As you can see that the board, that one is the PIR stuff, and this one is the board. And from the actually PIR sensor has a three output, which is a GND, 5V, and a data pin. With a GND is mean ground, so we can just connect the ground with the board ground one. And then the second one is to connect the sensor 5V, which is in the middle, and we will connect it with a V bus, which is in the corner one. Third one is we can connect the PIR sensor data, which is on the right, on the most right, and then we can connect it with the port GP28. And then the port GB4 is in this one, and it will be connected to the positive, one of the positive side of the piezo buzzer, and the other leg will be connected to the ground one, to the ground one. And here I wrote two types of codes. The first one is these codes. You guys can pay attention to this first. And on the first part is just import the system like time, board, tutorial, PMIO. And then the second paragraph is like input the codes for PIR and LED also buzzer. And in the third paragraph, you can see that if it is true, there is a motion, then in the output there will be a notification there is alarm motion detected, and then the light and buzzer will turn on. And when the motion detected false, there is no light and buzzer.
So that's big amount. You guys undergo it now. Wait. Huh? You guys undergo it now. And so
And here's the notification, but it's still blurry. And the second code is different from the first one, but from the first paragraph, the paragraph is same, but I just add more like improvisation because like if there is no motion or the motion detected is false, then the LED value is still, so the LED is still turning on, but only with a 0.5 interval, while if there is a motion, then it will be more faster, which is 0.5, 0.1. And this is the second gyro CPU. As you guys can see, the light's still turning on. And the next is the problems that I faced before. The first one is hard to find the BIR components because the teacher didn't give to us, then so I need to look for in Kuanghua with my friend Nicholas, and fortunately we find it. And then the second one is not suitable amount of resistor because the first I do like this experiment. I did it with 330 resistors with 330 ohms, and it didn't work, so I need to change it into 220 ohms. And the third one is be careful on the detail with coding because like parentheses, uppercase and lowercase is very important. And then the fourth one is the PIR was not accurate because like sometimes when there is a motion in front of the PIR, sometimes the PIR cannot detect and needs some time to be activate the light and activate the buzzer. And then the fifth one is the some errors in device. Like right now I'm using my friend's PicoPi because my PicoPi was broken and I don't know why. Even though it's on the outside was not broken, but in inside it's broken, so I need to borrow it first from my friends. And that's all from me. Thank you.